All right, so here we have a fun direct variation problem. It says the value of y varies directly with x. When y is equal to 75 and x is equal to 1/2, what is the value of y when x is equal to 2 1/4? Well, again, I'm going to make this, I'm going to convert that. So that's going to be 8, 9 over 4. Okay, I'm going to convert that to a improper fraction. All right, so direct variation problem is y is equal to kx, and we need to set up our table. I'm going to just plug these in. So 75 divided by 1/2 will give me my value for k. So k is going to be equal to 150. So k is equal to 150. Now I can find any value of y and any value of y, no matter what the value of x is, now that I know what k is. So I'm going to take that and substitute it back into my equation. So y is equal to 150x. Now I can plug back in my value that I'm given. Well, I'm going to use the 9/4. So I'm going to say y is equal to 150 times 9/4. So 150 times 9 divided by 4 will give me 337.5. Oops. Which is B. All right, let's see, problem number 10. All right, problem number 10 is one of those fun. We have a triangular prism, and its dimensions are shown in the diagram, and we're given the base. So remember, what is the lateral surface area of the triangle prism in square inches? Lateral surface area is going to be equal to, so lateral surface area is equal to pH. That's the perimeter times the height. So if this is 5, then that means that is also 5. So P is going to be equal to 10 is going to be equal to 16. So 16 times, so LA, or surface area, is going to be equal to 16 times 8. Which will be 128, which is G. So G is 128 centimeters square. All right, not too bad, right? All right, so number 11, that's a real quick and easy one. So Jillian made 25 international long-distance telephone calls to London last month. The scatter plot shows the length and cost of each phone call that she made. They're all over the place. It's non-linear. I mean, I can't make a line. If I make a line here, there's none of these dots are close to that linear line. So we can't really say that as the length of the call increases, it says what conclusion is best supported by the scatter plot. Okay. The length of the call increases. No, we can't really do that. The length of the call increases. The cost. Nope. There is no relationship in between the length of the call and the cost of the call. There's no relationship. Okay? Let's see. So let's look. What are the slope and y-intercept of the graph of the linear function shown on the grid? Well, it's not f, because our y-intercept is not -6. And it's not j either, because that says y-intercept of -6. It can only be one of these two. So we can solve this in a couple of ways. We can look at, it is a negative slope. We can pick 2 perfect points. I'm going to pick 2 perfect points. So I think that's going to be the easiest way for me to solve this one. Or you can just, you can do -2. You can use these 2 points that are given. So we can say -2 minus 0 over 2 minus 6. So So then that becomes negative 2 over 6, 7, 8, which will give me negative 1/4, which is h. But you could have also done down 1, so that's down 1. And so that means that's going to be negative, and then we're going right 1, 2, 3, 4, because there's a perfect point right there. So again, negative 1/4, same intercept. I'm going to finish this video, and then I'll go into the next one and the next video.